Friction is the force a surface exerts on an object parallel to a surface. We talked in a previous lesson about the normal force, which is the force that a surface exerts on an object perpendicular or normal to a surface. Friction is the force a surface exerts on an object parallel to the surface. Friction depends on the nature of the contact surfaces, the roughness of the surfaces, the materials, the geometry of the situation, and friction also depends on the normal force, that is, the one that is pressing the surfaces together. If we have a certain surface, say a table, and at the microscopic level a table is not smooth, no matter how it looks to us. There are mountains, there are valleys in the surface of a table, and if we have, say, a book that is on the top of it, if we want to slide the book across the table, it's almost like we're scraping one mountain range above across another mountain range below. So there's a little resistance to that motion, and we call that resistance friction. Now there are two types of friction. The first one is static friction. Static friction occurs when objects are not moving relative to each other. Let's say we have this mass here, and we're not pushing it sideways at all. In other words, this applied force is 0 newtons. There is no friction acting on that mass. If instead we push a little sideways, now not enough to make the object slide, but if we put an applied force sideways, static friction comes into play, and it will have a magnitude equal to that of the applied force. If we push a little bit harder sideways, still not enough to make the object slide, then the static friction force will increase so that its magnitude will be the same as the magnitude of the applied horizontal force. If we push still harder sideways, at some point there will be a maximum static friction value that can be obtained. We can't simply keep pushing sideways harder and harder and harder forever and the box never move. At some point the box is going to move, and the maximum force that we can apply without the box moving, that's equal to the maximum static friction force. If the applied force equals or exceeds the maximum static friction force, then the object will move, and then we don't have static friction anymore. The maximum static friction force can be found by this equation, mu sub s times the normal force, where mu sub s, looks like a cursive lowercase u, but it's actually a lowercase Greek m, which is why we call it mu. Mu sub s is the coefficient of static friction. The static friction force can take any value from 0 up to Fs max. Sometimes we have no static friction, sometimes a little bit more, up to some maximum value. Kinetic friction, which we symbolize F sub k, is sliding friction, and it has only one value for a given set of conditions. So this skier is sliding down the slope, and obviously there is kinetic friction because there's relative motion between the skis and the snow. It doesn't matter if you have speeding up sliding, slowing down sliding, or constant speed sliding. F sub k is F sub k is F sub k for a given set of conditions. Unlike static friction, which can vary, kinetic friction for a given set of conditions will not vary in this class. Kinetic friction is equal to the coefficient of kinetic friction times the normal force. For a given set of conditions, kinetic friction is always less than the maximum static friction. You may have tried to push a box and you might have noticed that it's tougher to get the box moving, and once it's already sliding, then it's not quite as hard, and that's because kinetic friction is always less than the maximum static friction. Final thoughts on forces 3. 1. While a normal force is the force exerted by a surface on an object perpendicular to the surface, friction acts on the object parallel to the surface. No matter the orientation of the surface, normal and friction forces are at right angles to each other. 2. With static friction, there is no relative motion between the surface and the object, despite sideways forces acting. 3. Kinetic friction is sliding friction. 4. A coefficient of friction is a number that accounts for the nature of the two contact surfaces. Bigger coefficients of friction mean stickier surfaces.